Hello everyone. Today we will study optics Unit 1, that is for BSc MSc second year. We will study all the units on optics. The first unit is nature of light and scattering. In that, today we will discuss about brief discussion of theories of light. So first of all, try to understand what do you mean by optics? Nothing but study of light, which can be broadly classified into wave optics and another is ray optics. So means you can understand that we'll discuss about the light, and our first unit is nature of light and scattering. So now, what do you mean by light? What is light? I'm sure you already know previously that light is a form of energy. But also you know, and we will at the end we will understand that it shows dual nature, both particle and wave nature. But our aim is we want to understand the theory behind it, how we can tell that light can be behave as particle as well as wave. So first of all, if I will ask, means light is a form of energy. If I will ask, can you show your energy? Can you show me the energy? Then definitely very difficult to show the energy. But yes, if you will tell slowly, and the same thing if you will tell loudly, that suggests that due to energy you can able to speak loudly. So you cannot show energy, but due to energy, you can able to show loud voice or any other things. So means the factors by which energy plays role. Similarly, if we discuss about light, the factors affecting via light we can able to tell it or we can able to see it. So if we want to see any color, how we can see that color? That is nothing but that light when falls on it. So particular that wavelength reflected from our retina surface so that we can able to see in that according to wavelength we can able to see the color. So what are the factors affecting my light? As you know, the reflection or refraction, that is nothing but your ray optics. Then interference, you know that we'll study in detail about this, all are in one chapter. Interference you have discussed in the unit on interference unit, like it can be constructive interference or destructive interference, diffraction, polarization, then photoelectric effect or Compton effect. So some part here we can able to see that wavic nature of light, and some part also are particle nature. So all we'll discuss all are unit diffraction, that is nothing but your bending of light. So then photoelectric effect, particle nature. So we'll understand in detail later. So now how, what are the theory behind it? There are various theory are there of light, but we will try to discuss few. Four, mostly four theory we will discuss. One is corpuscular theory of light, which was proposed by Isaac Newton. Next we will discuss about wave theory of light, proposed by Huygens. Next, electromagnetic theory of light, proposed by Maxwell, and quantum theory of light by Planck's, proposed by Planck's. So these four we will discuss in detail. So the first theory of light, that is corpuscular theory of light, which was proposed by Isaac Newton in 1675. So what exactly Newton suggested for this corpuscular theory of light? Now you just think about it. A light. Suppose we will glow a candle. What will happen? If we glow a candle, then definitely you can able to see surrounding the candle the light spreading throughout the surrounding of that candle. Similarly, also light source. If you show any source, what are the light sources? Like sun, we can say sun. From the sun, so radiated over the earth surface, or you can say if I take a bulb, then radiate it throughout the surfaces by light. So this Newton suggested that when the light spreads surrounding the candle, if you can see the candle, then this light, it consists of tiny particles. Not exactly here they're suggesting about particles, but saying tiny particles called corpuscles. The another name given, that is called corpuscles. So this light, whatever the spreading, so they're saying that this light consisting of very tiny particles. What do you mean by tiny particles? It means rigidity, or you can say elastic ball. We can think about elastic bulb. If you have an elastic bulb, if we want to throw the bulb, then it will bounce back. So in same direction it will bounce back. Or if you make some angle, and then also angle of incidence, angle of reflection will be remain same. So this type of tiny particles consists of composed for light, and these are called corpuscles. The next another experiment he did it. The experiment is very simple. You can also do it. Like if you can glue a candle, and then some cardboard you can take it. On the cardboard, 3 4 cardboard you can take it, and on the cardboard, same type cardboard, and then in all cardboard you just make hole in the same position. So then you just glue a candle on a surface, either on a table, and you put in small distance gap. You just put these three cardboards. Then now you just make that room completely dark. Then you can able to see the light on the screen. So means what it is suggest. So here how light travels, we can, if we can, how light propagates, if we can able to understand, then what it is suggests, we made a hole on the same position in three cardboards, but we can able to see the light on the screen, means the light travels in straight line, or the light propagates in straight line. So here Newton suggests that light consists of tiny particles called corpuscles that travels in straight line. So this is about clear about, this idea is clear. So means it was successfully explained about the propagation of light, how light travels. And next, that since it took is elastic ball, like tiny particles elastic ball, So now once some medium will be there, some rarer medium and denser medium, if it will throw, then definitely some velocity will be greater in denser medium will be observed. So by this way, Newton suggested that velocity of light in a denser medium is greater than the velocity of light in a rare medium. But if we can think about diffraction, is the same thing is happening? If we pass the light from rarer medium and denser medium, will we get this one? So it is a wrong statement which was later who rectified and all that we'll understand later, the next theory will understand. But Newton given the statement that velocity of light in a denser medium is greater than the velocity of light in rare medium. The next you can think that white light it consists of seven colors. So then why color changes? Why different colors you can observe? So for that answer, Newton suggested that these tiny particles or these corpuscles, the name was corpuscles, it has different size. So since different size, so that's why we can able to see different colors. So that's why the next statement, due to different size of corpuscles, they produce different colors. But now you can think it instead of corpuscles, if it will be wave, then the statement will be perfect because you can see if it will be wave, then you can see now if we read this instead of corpuscle, if we read it by wave, then you can see different due to different size of waves. Waves means it has different wavelength. We know that wavelength gives you color. So different wavelength, then different colors will come. But here it was the statement was different corpuscles suggested that different corpuscles shows different colors. So particularly for this case, we can understand that one thing at least we can clearly understand here, that is the reflection property, and another one that the travel, the light propagation. So particularly for this theory helps or explains successfully the phenomenon like reflection, refraction, and propagation of light, right? But what is the limitation? Limitation we can see if we want to see the diffraction, then it is not possible. So diffraction or interference if we can able to see it. So this theory failed to explain about interference or diffraction. So later in 1678 later comes wave theory of light proposed by Christian Huygens. So what he told, he was not satisfied with the concept of Newton. He told that he was not satisfied with this, that light consisting of tiny particles called corpuscles, he was not satisfied. What he told? He told that light propagates as waves similar to sound waves. Means what? Light propagates as waves. Suppose now you can think it. Suppose a calm water in a bucket, you will take it, and if you put a stone inside water, then what you can able to see it? You can able to see the ripple formation will occur around the waters in a circular form. Similarly, based on Huygens, he told that light also same way it radiates throughout that light. So it behaves like waves. Later we will understand about the Huygens principle and all about the wave fronts and all in detail about the in maybe after 1 or 2 class we can understand about detail about the Huygens principle that I'll go it. But now I'll just tell about the theory. So he told light propagates as wave similar to sound waves. But now again, he told one more statement that light requires medium for their propagation. As we know that on the Earth, after the Earth's surface, that is vacuum medium. No medium, we know that. So now the question comes then how light comes from sun to Earth's surface. So that time, Huygens suggested that there is a medium that is called ether medium. But since waving nature it was considered, and in this case he found that velocity of light in a denser medium is lesser than the velocity of light in rare medium. So it was here corrected, which we found the wrong in case of corpuscular theory was corrected here wave theory. Though that light needs a medium for their propagation, that is also again a wrong statement. We know that, but he corrected the higher corrected that velocity of light in denser medium is less compared to rare medium. So here the phenomenon like diffraction is easy or successfully explained. The phenomenon of refraction, diffraction, interference also very easily can be explained or successfully explained. But if particle nature you can see there is a limitation it failed to explain about photoelectric effect or Compton effect. But diffraction and interference can easily the waving nature can easily explained by Huygens. So, next, after around 200 years, electromagnetic wave theory of light comes into picture was proposed by James Clerk Maxwell on 1873. He told that no light for the propagation, no medium is required. He corrected it that no medium is required. But what he told, what he discovered, light is a form of electromagnetic radiation consisting of oscillating electric and magnetic fields. So here he told that it is a form of electromagnetic radiation. So both electric field and magnetic field will be there, and both are perpendicular to each other and also perpendicular to the direction of a propagation. And he rectified that medium not required for their propagation. So this theory successfully explained about the transverse nature of light. But it fails to explain about the particle nature if you can see like the Compton effect or photoelectric effect or blackbody radiation. It cannot help or it failed to explain about that. So next, quantum theory of light suggested by Planck's. and proposed by Max Planck on 1905. What he suggests, he told that the light is composed of discrete packets of energy called photon or quanta. So, like previously, we were saying about that wave and corpuscles, but here he told the quantum theory of light. He told that Max Planck told that light is composed of discrete packets of energy called photons or quanta. And what is the energy of these photons or quanta? This energy is proportional to the frequency of vibration. So if we calculate, E will be h nu or nh nu, and that h is a Planck's constant and the value is very small, that is 6.626 into 10 to the power minus 34 joule second. So if frequency you know, then you can able to calculate the energy of that photon. So this theory successfully explain about photoelectric effect and quantum effect. So this is all about the briefly discussion on theories of light. So usually 5 mark questions may comes in the question like briefly discuss about theories of light. So I just try to light in such a way that I just try to wrote the notes for 5 marks questions. So next we will discuss about dual nature of electromagnetic radiation. So next class we will discuss about the dual nature, means particle nature as well as the wave nature. We will particle nature and wave nature, how we can understand, like we know that wave means it has certain wavelength or amplitude or frequency. If these things will consider, then we can say that it's wave. Particle means it has certain mass, it has certain momentum or velocity. So in the next class we will try to discuss about the dual nature of electromagnetic radiation, and then we will also will discuss about, we'll try to find out also the energy stored per unit value volume of electromagnetic radiation. So thank you very much for watching.